All right, so the real reason I just showed you how to graph a probability distribution is that the kind of probability distribution we're going to be meeting today is one that is generally described in the form of a graph. And specifically, it's a graph that looks like this. So as you can see, there is a tall peak in the middle where the highest probabilities are. So remember, the height of the bars, or the height of the line here, is going to correspond to probability. And as you get farther away from that peak, you get into lower and lower probabilities. So your most likely outcomes are the ones in the middle, and your least likely outcomes are the ones that go out towards the sides. And this is called a normal distribution. The normal distribution is an important probability distribution for two reasons. One is that it describes a lot of phenomena in the natural world. Another, which we'll focus on a lot in this class, is that it's really useful in a lot of statistical applications. But the first thing I'm going to do is just introduce you to some of the places that you find the normal distribution out there in the world. A big one is in things like test scores. So when you're testing any kind of ability or knowledge, test scores tend to fall along a normal distribution. So if you look at SAT scores here, you can see that most people are likely to score around 1400 or 1500, and then you have fewer and fewer people who score very low on the SATs, and then fewer and fewer people who score very high on the SATs. So that's an example of a normal probability distribution. This is another example of a normal distribution. So this would be the birth weight of babies, and here it's in kilograms, but you can see that most babies are born with a birth weight of around 3.5 kilograms, and then you have fewer and fewer babies who are likely to be born very, very underweight, and then fewer and fewer babies who are likely to be born very, very large. So this is another example of a normal probability distribution. Another characteristic that you can measure of humans is height. And all of these I just pulled off the internet, by the way, which is why the examples are what they are. But this is a height distribution based on the heights of 3,000 adult English male criminals around 1900. So what you can see is that an adult male English criminal around 1900 is likely to have a height that's a little bit shorter than 5.5 feet. And then again, you're less and less likely to have somebody who's extremely short, and then you're less and less likely to have somebody who's extremely tall. So another example of a normal distribution. Pizza delivery times. So you've got a pizza delivery place that says it's going to deliver your pizza in 30 minutes. If you were to graph those times, you would see that the most likely amount of time that it's going to be before your pizza gets there is about 30 minutes. And then it's less and less likely that you're going to have a really short delivery time, less and less likely that you're going to have a really long delivery time. And then my final example, which always makes me hungry, is the number of calories in a Chipotle meal. And what you can see here is that this also follows a normal distribution, where if you get a meal at Chipotle, it's most likely that the meal is going to have around 1,000 calories, and then it's less and less likely that you're going to have a meal that has way fewer calories, and then less likely also that you're going to have a meal that has way more calories. And what you can see on all of these is that they're all described by this bell curve. And so what I'm going to do now is I'm going to hop into the document camera, and I'm going to talk a little bit more specifically about this normal distribution and what its properties are.